we are going to try to approximate the square root of 5 to 4 decimal places. Now, Colton, who said the first answer, 3.8, what would you approximate the square root of 5 to be? 2.1, 2.2. Sounds reasonable, huh? Let's try to get better than that, okay? So here's what we're going to do. We are going to create a curve, and the curve I'm going to create is x squared minus 5. What is the x-intercept of x squared minus 5? The y-intercept is negative 5. What's the x-intercept? The root of 5. Thank you. So if we want to approximate the root of 5, we need an equation, a function that has a solution of the root of 5. And it's just a parabola. It goes up. It does something like that, right? So here's what Newton did. It's a great idea. You got it. And it's not enough, you guys. I'll give you a formula in a little bit, but trust me, the formula is not enough. You have to understand this process. And it's just genius what he did. He says, well, I don't know what the square root of 5 is, so I will guess. And I'll make a bad guess. I'll guess 3. Is he way off? Way off. I guess 3. And when I guess 3, that will give me 3 squared is 9, minus 5 is 4, right? So that's going to be way off. But at 3, it will produce a point on the graph that has that solution. Understanding he is way off. Here's what he's going to do. He's going to say, now, given that point, I'm going to draw a line that is tangent to the curve. Yeah. What point on that line should he find if he wants to have a better guess than 3? What point on the line is closer to my actual solution? The x-intercept. Is it hard to find the x-intercept of a line? No, it's easy. We do it all the time. So you just calculate that. Well, that's better. What if you want even a better one? Make that my new guess and do it again. Find a point on the curve, draw the line. Before you know it, you're basically right on top of the x-intercept. Not only that, but you have a rational approximation for an irrational number. Sweet, huh? Let's derive the formula, and we will use the square root of 5. First of all, you need to come up with a function that has a solution of the number that you're approximating. So in this situation, our function was x squared minus 5. You have to come up with it. You got to be able to think it through. So what if I said square root of 2? You'd have x squared minus 2. What if I said the cubed root of 4? X cubed minus 4. See, we can do that, right? So now we need an initial guess. What was our initial guess here? 3. Our initial guess we're going to call x sub 0. Sub 0 meaning not below 0 like temperature, but like very first one. Okay. So our guess is x sub 0. Once we guessed in this situation, so what I'm going to do is we're going to do a real example, and we're going to outline the formula at the same time. So this side will give me the formula. This side will actually allow us to approximate. Okay. So once I guessed 3, what did I then do? I came up with a point on the curve, yep, which ended up being on the line. So point on the curve. How would you come up with that point on the curve? Yeah, 3 is your x value. How would you get the y value? You plug it in, and you get 3 squared is 9 minus 5 is 4. So the point on the line, what will be the x value for the point on the line? X sub 0. what will you do with x sub 0 to get the y value? You plug it in. You get f of x sub 0. Okay, got a line. I need slope. Slope, slope, slope. In order to find the slope of that line, what do I do? Take the derivative. Yes. What is the derivative of x squared minus 5? If the derivative is 2x, what's the slope? 6. You plug in what value? Plug in your 3, so you get 6. So your slope is equal to 6, and your point on your line is 3, 4. So those are the two pieces that we have. So if we want to find the slope here, we take the derivative of f of x. What's the derivative of f of x? F prime of x. And instead of plugging in x, we plug in x sub 0. So you can see here we have slope and we have a point on our line. Here we have a slope and we have a point on our line. Everybody see how those match up? Let's now find our guess. We need to write an equation for the line. Y minus 4 is equal to 6 times x minus 3. If we are finding the x-intercept, what is, or what value do we know at an x-intercept? If you're solving for an x-intercept, any function, the y value is 0. Everybody agree? We're going to take y, we're going to set it equal to 0. Now we solve for x, and that will give us our new guess, which is much closer to the correct answer than our initial one. So we will divide by 6. Negative 2/3 is equal to x minus 3. Add the 3. 3 minus 2/3 is equal to x 7/3. Because y is equal to 0 when you make the x-intercept. So what we have here is if we actually take the square root of 5, you can see that we get 2.236. Well, that's actually pretty close to 2.333, right? Now, is it close enough? Probably not for what you want, so do it again. You just do it a couple times and you're good to go. You got the second calculate button right here where you find a 0, right? A lot of calculators actually use Newton's method in order to do that. Let's do the actual algebraic piece here and work this through. The equation for the line will be y minus, what is my y value here? F of x sub 0 is equal to, what's the slope? F prime of x sub 0 times x minus x sub 0. Now that looks like a lot of garbage, but the fact is we'll get it to work out pretty nicely, okay? Don't worry about it. We're finding what spot on the line? The x-intercept. So if I'm finding the x-intercept, that means I set y equal to 0. So I have negative f of x sub 0 is equal to f prime of x sub 0 times x minus x sub 0. Like over there, I divided by 6. I divide by my slope, so I'm going to divide by my slope here. Divide by f prime of x sub 0. And I get that. Negative f of x sub 0 divided by f prime of x sub 0 is equal to x minus x sub 0. I'm trying to find x. So I'll add the x sub 0 over to the other side. X sub 0 minus f of x sub 0 divided by f prime of x sub 0 is equal to x. I will write sub 1 because it is my new guess. I solved for x right here. I'm calling it x sub 1 because it's my new guess. This is the formula for Newton's method. It is genius. What does it do? It does what we saw up in the picture up there. It takes a guess. It finds the equation for a line tangent. It finds the x-intercept, and it does it like that. Now, you guys get a choice here. We can either say, oh, let us put ourselves in the situation that Newton was in, where we have no calculators, and we will do this all by hand. Or you could say, I think we understand what that's like well enough, so let's use the formula, but also use our calculators to help us out. Which one do you want, option 1 or 2? Okay, because if you want 1, go ahead, do it, but a couple of years I've gotten criticized, like, you're cheating using your calculator. Well, we just don't have time, okay? So if you want to do it, go ahead. Go ahead, don't use your calculator. Throw it away, bust it up, get a hammer. So, I've got a good guess. I've got 7/3. I want to approximate the square root of 5 to 4 decimal places. I have 3 pieces here. I have a function, which was x squared minus 5. I have a derivative. What was the derivative? 2x. And I had an initial guess. X sub 0 was 3. X sub 1 is 2.3333, 4 decimal places. I'm always going to write out to 4 decimal places. And here's how you know when you're done. We're going to take 2.333. 2.333 is 7/3. And I'm going to subtract 2.3333 squared minus 5 divided by 2 times 2.3333. Where did I come up with that? Yeah, that's this thing right here, right? So I'm going to use Newton's method. I'm going to use the formula. I'm going to come up with a new result. Okay, so I've got, this is x squared minus 5. This is the derivative right down here. See how all the pieces are in place from this? Let's do it. So it's, look at our formula. It says f of x sub 0, f of our guess. Well, so now, so we're changing the formula. Now it's 1, 1, 1, and 2. And it'll be 2, 2, 2, and 3. So we're always going to put in our new guess, and it'll give us a new one. Okay? So I'm going to punch it in. Take out your calculators, because I'm going to show you something to save you time. 2.333 minus parentheses 2.3333 squared minus 5 parentheses divided by parentheses 2 times 2.3333. I just type it in. I press enter. I got 2.2381. Did your second guess change from your, I'm sorry, this is actually your third, isn't it? Did this change from your previous one? Yeah, so we're not done. We need to do it again. I'm going to show you something to save yourself time. Instead of typing it all in over again, just do second entry. And go back and change what you want. You got 2.33. I'm going to go 2.2381. 2381. 2381. Well, just because I don't have to type it all in again. So I'm doing the same thing. I'm doing 2.2381 minus 2.2381 squared minus 5 over 2 times 2.2381. I'm doing the same formula again. I did second entry so I wouldn't have to type as much. I press enter. I get 2.23 6-1. Is that different from my previous guess? Is it different by much? Not really. It says it has to be accurate to 4 decimal places. And as long as it continues to change, it's not accurate to 4 decimal places. So we're going to try it again. We're going to take that entry. If you want to be accurate to, say, the 10th, then you'd be done. But that's not good enough for us. So I'll change that to a 6. 6. Change that to a 6. And I get 2.2361. Did that change? No. So it looks like 2.2361 is a really good approximation for the square root of 5. Let's see if it really is. 2.2361 squared, and you get, that's, Colton had a really good guess right away. He guessed 2.1, okay? And 2.1 is close, but that's nowhere near as close, is it? We'll give him benefit of the doubt. We'll say 2.2. Still, I mean, and look at that. We didn't have to spend that much time even, right? So you got to have two things in mind, the formula, but also the understanding of what the calculus does. We got 3 minutes, and I think that's going to be enough time. Flip it over and use Newton's method to find the following to 4 decimal places. This is what you want to try to memorize, x sub 0 minus f of x sub 0 divided by f prime of x sub 0. If I'm finding the square root of 7, what is f of x? X squared minus 7 would have a solution of square root of 7. Good. What is f prime of x? And what is your guess? Sure, guess 2. Go. See what you come up with. Against the room, we do math. Sure. Is she in big trouble? Yes, thank you. Excellent. Yep. Bye. Obama says you're in big trouble. Let's go. Come on. I receive. Handcuffs will not. Oh, sorry, YouTube Nation. I totally forgot to turn the mic back on. So this is the assignment that we did. So I want you to do page 298, problem 4, 11, and 12. Maybe before you do 11 and 12, do these two. Find the cube root of 24 and the fourth root of 56 to 4 decimal places. Yeah. So you kind of, no. No, Haley, the whole assignment is fun this time. Okay? What? No, 4 is a graph like we just did. So your book puts the graphs first and then the other part second. So we kind of did the graph first and then the other parts and then the graph again. So I just want you to understand what you're doing with each problem. And then YouTube Nation, this at least you can see kind of, I'll at least show you, this is what we covered. So we, here was our work for this part B. We did part A in class. People did it on their own. Part B, this was our function. This was our derivative. This was our guess. Here was x1. Here was x2, x3, and x4. We used our calculator. And the red graph is our function for 2. You can see this is what we come up with for these pieces. So if you're in my class, you probably need to see me to figure that out. So have a great day.